Hello, everyone. I hope everyone is doing great, and I also hope that you guys are following this course. Now, as I said in the beginning, I'm covering each and every topic from the very basics of it. So it is easy for you to understand. Also, I'm going in sequence, as you might know, so that everything will be in sync and you will be able to relate each and every topics that I am covering. And if you're visiting this course for the first time, I would request you to please subscribe my channel and like the videos. It will make you also understand what are the topics that we're covering as we're going along in this machine learning course. And also it will motivate me to make more and more videos on these topics. So do subscribe the channel and please share within your communities, your friends, your colleagues who are interested in data science and machine learning. I also made an announcement in my previous videos that I will cover deep learning as well. So once we finish the machine learning and we do a couple of hands-on experiments and we know the core concepts in machine learning, then we will dive into deep learning concepts and algorithms. So having said that, let's start today's tutorial. Now, today's tutorial, guys, we will mainly talk about inferential statistics. I guess you guys might know about this term as I have discussed this in my previous videos. Again, guys, since I'm going in sequence, so please refer to the previous videos if you haven't gone through them. So statistics mainly broadly we divide into two categories: inferential, descriptive. So this is a part of inferential statistics. So what exactly it is? Basically, we're trying to using statistical tools, methods, we're trying to infer about the population, right? We're trying to draw some opinion, some speculations about a particular population. Okay, so this is the whole idea. Now I have divided this session into two sections. In today's sections, I will be covering the part one, and in the next section, I will cover part two. Okay, so part one basically deals with the concepts. So these are all the concepts that we'll learn. And once we are ready with the concepts, we'll directly do some experiments with these tests. So this, what are these tests and all I will explain in later videos. So now let's understand these five topics in today's class. What is significance level? What is confidence level? What is confidence interval? What is p-value? And what actually are null hypothesis and alternate hypothesis? Now, many of you might have already heard about p-value, null hypothesis, alternate hypothesis, and all these terms. But right today, I will describe in detail exactly what these concepts are so that it's easier for you. So let's start. So now, let me first discuss about this null hypothesis and alternate hypothesis. So what exactly is hypothesis? Hypothesis in normal terms, it means some sort of opinion, maybe, or a theory, or some speculations. In general term, hypothesis means this following terms. It may be a theory that we want to prove. It may be an opinion that we uh, want to say about a particular population, or if you want to draw some speculation about a population. So this is hypothesis. Now there are two types of hypothesis. One is null hypothesis and alternate hypothesis. What are these actually? Null hypothesis is when you have nothing in hand and before performing any tests on any particular population, let's say uh, let's say the most plausible explanation the most plausible explanation that you have in hand in hand can be our null hypothesis. Okay, and it is denoted normally as H naught. Now, what exactly do we mean when we say when we say this term, most plausible explanation? Now, suppose, let's say, let me go to another video, another screen. Okay, so let's say there is a company. Okay, so there is a company A, and there are 100 employees in that company. Now, some person from the company said that, okay, the average salary in the company is, let's say, 50K. Okay, now what we did, we collected few samples. Let's say we collected 40 samples, 40 employees salary. So 40 employees are nothing but samples, let's say. So we collected 40 samples and we found out that the average salary was around 35,000. Now there is a trial. Trial in the sense, think of it as a trial. So then what is a null hypothesis here? Null hypothesis is the average salary that they are claiming. Okay, average salary that maybe the HR people over there in the company, they're claiming it to be 50K. But we are saying, when we are protesting, we are saying no, it is 35K. Okay, so now there is a trial. Just imagine, guys, you are in a court, like you are in a court, and you have a judge sitting, and then there is a trial happening, and you are protesting. So this is our, let's say this is our null hypothesis. Just think hypothetically, guys. So this is our null hypothesis, meaning this is our theory that the average salary is 50,000. Okay, and we are conducting a trial. So what is the alternate hypothesis? Alternate hypothesis which is also denoted as HA, is that the average salary is not equal to 50,000. Not equal to 50,000. So what we are protesting is to the judge is that the average salary is not 50,000. But this guy over here, he or she is saying no, the average salary is 50,000. So the trial is basically is done based on some statistical statistical tests. So based on some statistical tests, we will conduct the trial, and then we will come to know whether the null hypothesis is correct or the alternate hypothesis is correct. Meaning, for this case, whether the average salary is 50,000 or it is not 50,000. So this is a null hypothesis, and this is also alternate. So alternate is just the reverse of null hypothesis. So for conducting a trial, we need to have one particular idea, right? Or maybe one particular reference point. One particular reference point. Based on it, we will perform our experiments. Based on it, we'll perform our experiments, and we will get to know whether our results is similar to this reference point or it's not, right? Think in this way. So for every experiment that we do, we will have one null hypothesis, and corresponding to it, there will be one alternate hypothesis. And based on it, we'll perform our statistical tests, which are nothing but these tests. Okay, I will cover these tests in my next video. But for now, you just understand the idea. Okay, why we are doing this test? We are basically trying to get some inference about the particular population. So in this case, about this company, whether this company's average salary is 50K or not. This is a problem statement. So we are assuming first that yes, it is 50K. So our null hypothesis is 50K. And then the alternate hypothesis is no, it is not 50K. So this may be one of the examples. Okay. So this is null hypothesis and alternate hypothesis. I will cover this particular portion also in the next video when I will be performing this test. Okay, each of these tests, guys, will have null hypothesis and alternate hypothesis. First, I will discuss about some theory, and then there will be some practicals, hands-on, where we will be conducting this particular test on those examples. Okay, for now, just understand the theory. So today's lesson is all about theory. So we know what is null hypothesis and what is alternate hypothesis, right? To summarize, null hypothesis is something that we basically assume at the very first when we are conducting the trial or when we're conducting the experiment. There has to be a reference point, a base point. So that's the null hypothesis, and it is always a true value. It is always a true value. Okay, that's why it is saying most plausible explanation. Okay, so meaning the most accurately or most viably, this is the value that can be. For example, in this case, the most plausible value is 50K only. That is what we are assuming. But what exactly, whether it is actually 50K or not, we are performing some tests to find it out. So you know now what is null hypothesis, and also you know what is alternate hypothesis. Null hypothesis denoted by H naught, and alternate hypothesis denoted by HA. Okay. Now let's understand what is significance level. Okay. Let me go to the other slide. Let's understand significance level. Significance level. Now, when you will search, guys, these topics in internet, there will be lots of discussions and lots of explanations. But I'm trying my best to make it as simple as it is, so that it's easy for you guys to understand. Okay, and then you can refer other sites and get your idea more clearer on these topics. Okay, so this can be as a base. So what is significance level? Significance level tells us that basically it's a probability of rejecting our null hypothesis. It's the probability of rejecting our null hypothesis even when it is true. What does it mean? It means that even when we know that our null hypothesis is true, meaning in our previous case, the average salary actually is 50K, but even though there is a probability of rejecting, so there is some probability or some margin of error for this. Now, let me explain actually. What does it mean? Let me explain in a very simple way. But this is the definition of significance level. Probability of rejecting our null hypothesis when we know that it is true actually. Our null hypothesis is true. So what is it actually? Let's say there are two places A and B. Okay. So, and you are traveling from A to B. Okay. Let's say you are traveling from A to B. So when you are traveling from A to B, the total time taken maybe let's say 40 minutes. Okay. This is a very common example, guys. Let's say you are traveling from place A to place B. Places can be anything, just you imagine. And the time taken for you to reach place B is 40 minutes. Let's say another day you traveled and it take around 38 minutes. Okay. Now let's say another day you travel, it take around 45 minutes, and it another day you travel, it take around 50 minutes. This may be depending on the traffic. You know, this may be depending on the traffic or when you have started your journey. Maybe you started late and the traffic was huge, so it took around 50 minutes. Maybe again you travel and it took you around 40 minutes. Again, it took around 40 minutes, let's say. But fewer days when there is less traffic, it took around 35 minutes or maybe 30 minutes even. So assume that this you are traveling per week. Let's say you're going to an office and you're going, maybe you can consider it as an office also. Let's say you're traveling from, and your location, your where you're staying is a bit far from where your office is, let's say. Okay, so you're traveling every day, 5 days a week you're traveling to your office, and these are the time that it took to reach from your home to the office. Now this can be a sample, right? Let's say 1, 2, 3, 4, 5, 6, 7, 8. Let's say we collected 8 samples, right? Now if I ask you how much time it takes for you to travel from your home to the office, you may say it takes roughly around 40 minutes from these observations, right? Roughly around 40 minutes. Now I may ask you, okay, how much confident are you? You may say you are 95% confident. You are 95% confident that, you know, you will reach from your home to your place, to your office, within this 40 minutes time. Now, this 95 minutes is called confidence level. Many of you guys may may be confused by reading different topics in the internet, but this is actually the real meaning of confidence level. So when you say 95%, you are confident that to reach from your house to the office is 40 minutes, and this is nothing but the confidence levels. Okay, and remaining 5% is margin of error, because overall you have 100%, right? So if you're 95%, you're saying that I can reach in 40 minutes, remaining 5%, you are not correct, right? Maybe you are wrong. So this is margin of error. This is also denoted as alpha, and this is also known as significant level. Okay. So you see, probability of rejecting our null hypothesis. This is the probability of rejecting our null hypothesis when we know it is true. So this is the error. This is the error rate. Okay, this is the error rate. You can denote it as significance level. You can say it as significance level or margin of error, or margin of error. Short form is MI. So if you're 95% confidence that you can reach that place in 40 minutes, that means 5% you are not confident, and this 5% is your margin of error or significance level. So what is significance level? It is the probability of rejecting our null hypothesis. Our null hypothesis is we can reach in 40 minutes, and we know we can reach in 40 minutes because we have the survey in hand. But 5% there is margin of error or significance level. So this 5% also we can say it as 0.05, right? We can say it as 0.05. So 0.05 is the significance level. Okay. Now you can also say that you are 97% confident. In that case, what will be the margin of error? It will be 3%, right? So before conducting an experiment, this is one of the examples I've given, but before conducting any experiments, let's say for this trial is an experiment. So before conducting this trial, we first set our margin of error. Okay. Up to what extent we can accept the errors. This is something that is given by our domain expertise. Okay, domain expertise. Whether it's 3% or 5%. Okay, this is given by domain expertise. They will decide how much margin of error we can accept for our experiment. If it is very critical, they may reduce it or they can keep it. Normally, they keep it at 5%, which is 0.05. So this is all about significance level. And also, you know what is confidence level and what are these basically? These are the intervals, right? So your value 40 falls in this range. This is the range of results that are this is a range of results we got when we performed the survey, when we performed or when we performed the experiment. Okay, so these are nothing but these are the confidence intervals. Confidence intervals, and we know that our average value, or let's say the accurate time to reach from point A to point B lies within this confidence interval. Lies within this confidence interval. So let's say if we call, just assume it to be a straight line where I'm basically this is a time. Okay, let's say this is a time. Let's say this is 40, this is 45, this is 50, and this is 55. This is 35, 30, this is 25, something like that. Okay, so these are nothing but the confidence intervals. Okay, you see the values, after the experiment, and then you draw the confidence interval. So these are nothing but the confidence interval. Now, your from this particular experiment, if you see, I don't want to confuse you guys. Your confidence interval from 30 till 50, I guess. So this will be the confidence interval for this experiment, for these values. These are the confidence intervals, and your value lies within this confidence intervals. Now, what is the value? What actually? So you think that this is a population. You are conducting some experiment on this population. Why? Because you want to know something about the population. You want to find out some parameters of the population. Let's say the average. Let's say the average you want to find out. So average, let's say if you consider this scenario, average time to reach from A to B is 40 minutes. But you conducted different experiments. So you have taken out samples. You have tried out 5 days, let's say in a week, and you got different results. And in these different results only, you have your actual value. So now you know what is confidence interval, what is confidence level, and what is significance level, right? So this was all about significance level, confidence interval, and null hypothesis and alternate hypothesis. Now, what is p-value? This is a very important concept, guys. And normally you will, when you will perform experiments, you will seldom come across this particular terminology. P-value is nothing but the probability of your null hypothesis to be true. This is the definition of p-value. It is a probability of a null hypothesis as true. So now you know the significance level, right? It is 0.05. If your p-value is less than 0.05, it means the probability of your null hypothesis is less than their significance level. So you will reject your null hypothesis. You will reject your null hypothesis. Now, rejecting null hypothesis, accepting null hypothesis, I will also cover in my next video where there is a formula that you should remember, guys. That when this is something that will really help you in your forthcoming sessions and all through your life. Just remember this: when P is low, null will go. This I learned from my mentor, and it really helped me to remember. When P is high, null will fly. It means when P value is lower than your significance level, you will reject your null hypothesis and you will accept your alternate hypothesis. When your P value is greater than your significance level, you will accept your null hypothesis and you will reject your alternate hypothesis. So this is very important and very very crucial to keep in mind forever. When P is low, null will go. When P is high, null will fly. When P is low, you will reject your null hypothesis. When P is high, you will accept your null. So you can remember with this particular proverb, you can say. Okay. Now, what do you mean by when we say P is less than 0.05? Means that probability of your null hypothesis to be true is less than 5%. So it means what? Probability of your null hypothesis to be true is less than 5%. If it is less than 5%, right, then you will definitely reject, right? You will definitely reject. You will not accept. So this is about p-value. So what is p-value? P-value is the probability of your null hypothesis to be true. So in this particular experiment, let's say this experiment, we first of all, before performing the experiment, what we do, we as a, as a domain expertise, they set the significance level as 5%, or let's say 0.05. 5% is nothing but 0.05 margin of error. It means they can accept errors till 5%, not more than that. Whatever experiment we're doing, okay, 5% error they're accepting, not more than that. So what is the inference? It means our p whatever way we calculate the p-value from this experiments, if it is less than this value, then this particular hypothesis will go wrong. Okay, then we need to accept the alternate hypothesis, which means average salary is not actually 50,000. It is something else. It may be lesser, it may be greater than that, but it's not 50,000. Then this particular guy will be convicted. Right? If our p-value is higher than this, meaning our probability of null hypothesis, sorry guys, if a probability of null hypothesis is greater than this value, this margin of error, then we will accept, okay, whatever this guy, the HR or whoever is representing this case is saying is correct, and the average salary is 50,000. So we'll accept it. So our whole concept of whether accepting or rejecting depends on the significance level, and whatever p-value we are calculated, whatever p-value we are getting after doing this experiment. Now I hope this is clear, guys. So I talked about null hypothesis, I talked about alternate hypothesis. Hypotheses are nothing but opinions or survey or speculation that we are doing, right? So before doing any experiment, we should have a null hypothesis, and also we should have a significance level, meaning margin of error we should decide, right? If my p-value that I'm calculating which is the probability of that null hypothesis is true, is more than this value, then only we'll accept our null, or else we'll reject our null hypothesis and we have to go with our alternate hypothesis. Hypothesis, what we're basically doing, guys, we are trying to predict something about some population or some theory that we have in hand, right? And these are the benchmarks for us. Based on this, we're predicting something. Now, we also talked about confidence level, right? 95%. So 95% confidence that this uh, in our last case that we saw right here, 95% confidence that the distance time taken from point A to point B is 40 minutes, right? So this is the confidence level. And there is something also confidence interval. Confidence intervals are nothing but the range of values that we are getting, and within this value, the true parameter of the population lies, right? So within this range, what is the range? Confidence interval range. Range we got after we perform the experiments. So within this range, the true parameter, this is very important, guys, to remember. The true parameter of the population lies. So you see here, 40 lies in this particular interval, right? So that's the confidence interval. So this is the range where the true parameter of the population lies. Okay. So this was the theory part of these concepts. Now in next lesson, I will cover the part 2 of this series, which is Z test, T test, F test. What are all these tests? Why we do these tests? So we'll cover them out. That's it, guys. If you like this video, please subscribe the channel. Please like this video, share as much as possible. And that's it. Thank you, guys. Keep learning and keep shining.